Welcome back. This short video is going to talk a little bit about relativism in science, the case of Thomas Kuhn. Now, I'm neither a scientist nor a philosopher of science, and about the only philosophy of science that I thought about is relativism and Thomas Kuhn's work on scientific revolutions from his book, The Structure of Scientific Revolutions. So this little selection I'm going to be walking through is from my book called Relativism, A Guide for the Perplexed. It came out a few years ago, quite a few years ago now, but this little section deals with relativism in science. So Thomas Kuhn's notion of a paradigm, one way of understanding the concept of a worldview, might fit the bill for the standards conjunct of a definition of relativism that I've been using in this book. So by the standards conjunct, I mean if relativism, the kind that's self-refuting, is going to be asserted, it's usually asserted by two conjunctive ideas. One is that for any epistemic claim, for any truth claim, that claim is evaluated by some standards of evaluation. And then the second part of the description of relativism that's self-refuting is that not only is there standards of standards of evaluation, which I don't think is that big of a deal, but the big deal is the second conjunct in a description of relativism, which is the idea that when there's two competing standards of evaluation, there's no neutrality between them, and that logically produces the self-refuting nature of relativism. So Thomas Kuhn's notion of paradigm, which he uses in his work, might fit the bill for the standards conjunct. So the paradigm, according to Kuhn, is a scientific achievement that has two features. One, it was successful enough in solving problems that it drew adherents away from competing modes of scientific activity. And two, it left a number of problems unsolved to be worked out by a new group of scientists. So that's what he thinks a paradigm is. As Kuhn's work comes out in the mid-90s, this Structure of Scientific Revolutions. Paradigm, in this sense, may be a necessary condition for making scientific judgments, much in the same way a standard of epistemic evaluation is used to justify or establish or make reasonable any type of belief. For example, Kuhn gives a case of a chemist and a physicist being asked whether a single atom of helium was or was not a molecule. The chemist from his paradigm answers yes, and the physicist from his paradigm answers no. This seems to indicate that the answer to specific scientific questions is a matter of reference to a paradigm. This seems to be a case of the standards conjunct and the definition of relativism I'm using in this book. So what about the no neutrality conjunct? Okay, does Kuhn maintain that? Now, if he does, then that's going to be a form of relativism, which might entail a self-refutation problem, which always is a bad outcome for your philosophy of science. In his introduction to his chapter, Revolutions as Changes of Worldview, Kuhn writes, quote, "The scientist can have no recourse to what he sees with his eyes and instruments. If there were some higher authority by recourse to which his vision might be shown to have shifted, then that authority would itself become his source of data." End quote. Now, this seems to be a denial of a kind of extra-paradigmatic standard for scientific judgment, i.e. no neutrality. Several other examples that Kuhn gives seems to point this way, too, such as the discovery of Uranus, the planet. It was thought once to be a star, then a comet, and finally a planet. And once it was recognized to be a planet, this is quoting Kuhn now, there were several fewer stars and one more planet in the world of the professional astronomer. Now, this could be interpreted as a kind of ontological relativity in the heavenly body that we call Uranus was once a star, and once a comet, and that is now a planet. So Kuhn uses this locution, quote, "Though the world does not change with a change of paradigm, the scientist afterwards works in a different world." Working in a whole new world. Does this amount to a denial of neutrality? Kuhn seems to equivocate on this point. On the one hand, he claims that he finds it, quote, "impossible to relinquish the notion of neutrality, but on the other hand, to claim that it no longer functions effectively." He further states, "No language thus restricted to reporting a world fully known in advance can produce mere neutral and objective reports on the given." It's kind of the given, the myth of the given. I think that's a myth at all, but it's more the myth of the taken, as Dallas Willard pointed out once. These quotations seem to point a rejection of neutrality between competing standards of the justification of scientific beliefs. Okay, so if in these examples, Kuhn means his examples to point to a strong rejection of the possibility of neutrality between competing paradigms, and it seems to me that his views lead to a form of relativism that will have the same problems as other forms of relativism, namely this self-refuting. But Kuhn's denial of neutrality may only be a denial of global neutrality, i.e. denial that there's one fixed standard of neutrality that solves all disputes for all times. Kuhn may not be denying local neutrality, the possibility of standards that can be had between particular competing standards of epistemic evaluation that occur in specific scientific disputes. So maybe he's got this more limited notion of neutrality he's working on. So here's an example from the history of science. Ptolemaic astronomers attempted to establish the proposition P, where P is the Earth is the center of planetary motion for our system, planetary system, by means of the following standard of evaluation. So this would be a Ptolemaic standard of evaluation. Conceptual economy, the ability to explain common sense experiences, and understandability. On the other hand, Copernican astronomers attempted to establish proposition Q, where Q is the sun is the center of planetary motion. It's the center of our planetary system, by means of a standard of evaluation S2, where S2 is fruitfulness, for example, i.e. that is the effectiveness of theories as guides for research and frameworks for the organization of knowledge. Right? So you've got now these two propositions and two different conceptual schemes by means of which, or we call them paradigms, which are standards of evaluation, one Ptolemaic and one Copernican. Okay, so now the question is, what do you do in cases like that? Right. So according to the relativists, given these different standards of evaluation, there's no neutral way to determine which standard to use. And thus there's no neutral way to establish P or Q over and above the other. Right? So the Ptolemaic and the Copernican astronomers are kind of stuck here. However, contrary to the relativists, the mere fact that S1 and S2 are different standards of evaluations means neither that there can be no neutrality between them, nor that the propositions established by them can be established as superior to the other. Rather, this means that if each side understands their standards to be established for non-question making good reasons, then each side is committed to the possibility of local neutrality. Okay, so that would be a notion of local neutrality in this astronomic debate. So Kuhn indicates that each side in this dispute between the Ptolemaic and Copernican views of astronomy held their standards for what they took to be non-question making good reasons. One of the main reasons that each side maintained the standards they did included the ability of their standards of evaluation to, quote, solve the problems of planetary motion. They took this reason to be non-question making and non-arbitrary. Ptolemaic astronomers thought that these problems were solvable by the addition of multiple epicycles. It's the little spinner epicycles on the motion of planets. And Copernicus thought that the Ptolemaic view was incompatible with and simpler than available astronomical observational data. And thus one of the reasons Copernicus rejected the Ptolemaic model was that it did not seem to solve the problems as well as the Copernican model. Now, according to Kuhn, Copernicans also held their standards for reasons of quantitative precision as a kind of problem-solving ability. Kuhn states this quantitative superiority of Kepler's Rudolphine tables to all of those computed from the Ptolemaic theory was a major factor in the conversion of astronomers to Copernicanism. It's on page 154 of his book. Another example of what Copernicans took to be non-question making good reasons for holding standards that they held is shown in Kuhn's indication that Kepler's ability to use his mathematical models, combined with the data of Tycho Brahe's observation, allowed him to develop a simple mathematical technique that yielded predictions of planetary motions far more accurate than any that had ever been made before. That's what Kuhn says. His book, Ideas, articles from 1957. It was been a while from that one. The Copernicans' commitment to non-arbitrary good reasons for the standards that they had implied that they were committed to the possibility of locally neutral standards that could settle their dispute with the Ptolemaics. So this example shows that one can maintain the standards conjunct of relativism and deny one type of neutrality, say global neutrality, without the resultant problems of relativism raised above. In this account, taken from Kuhn's work, no relativism entails since there's no denial of local neutrality. The shift from a Ptolemaic Copernican astronomy was not an arbitrary relativist paradigm shift. It was one based on non-arbitrary good reasons for the standards that were held by the disputing parties. The reasons for the standards were held by each of the parties, thus a resolution of the conflict could in principle be had without a slide into a form of subjectivism or relativism. Okay, so in fact, responding to various critics of his own views, Kuhn seems to maintain just this point. There can be local neutrality between competing scientific paradigms. One critic of his views claims that Kuhn's apparent denial of neutrality leads to a kind of relativistic situation, in which the decision of a scientific group to adopt a new paradigm cannot be based on good reasons of any kind, factual or otherwise. Now, Kuhn is careful to explain that there are characteristics, apparently neutral ones, that can be used as marks of good scientific theories. He lists 5 of them: accuracy, consistency, scope, simplicity, and fruitfulness. Now, given such a list, one can hardly accuse Kuhn of relativism regarding paradigm change. However, and this is where relativism might creep in here in this philosophy of science, Kuhn does claim that in addition to these objective criteria, a choice between paradigms, quote, depends on a mixture of objective and subjective factors, end quote. Now, this might just be what leads to accusations of relativism in Kuhn's work, but relativism need not follow as long as neutrality, even if localized, can be had between competing standards of evaluation. As long as philosophers of science do not deny the possibility of neutral among paradigm or worldview choices, relativism need not follow. Now, if neutrality is denied, the view falls suspect to the general self-refuting arguments raised against epistemological relativism in Chapter 2 of this book and elsewhere that I've argued. So maybe I'll just close with this. It seems to me that in any philosophy of science or in any epistemology of science, scientific inquiry, what counts, what is neutral between competing paradigms is reality itself. And I think that's going to be the case for any area of human inquiry, whether it's scientific, philosophical, theological, moral, aesthetic, political, whatever. Reality is neutral between competing beliefs that we have. Things are what they are. All right, thanks for watching.
Stay psyched, Grom.